This is part 5 of square roots and radicals, and in this video we're going to go over how to simplify square roots. So first of all, we have to know how to tell if a square root is simplified or not. A square root of a counting number is considered simplified if no factors of the number are perfect squares. So for instance, let's say we were looking at the square root of 15 and we want to know if that's simplified or not. Well, if I look at the factors of 15, they're 1, 3, 5, and 15. And none of these are perfect squares. So therefore, square root of 15 is simplified. Okay, so we can't go any further with that one. Now, let's say we were doing the square root of 12. So let's just list the factors of 12. We would have 1, 2, 3, 4, 6, and 12. So the question is, do any of these factors here, are they perfect squares? And yes, 4 is a perfect square. So this means square root of 12 is not simplified. Okay? So that's how you could tell if you list the factors. Now, you don't want to have to go through and list the factors each time necessarily, but I'm just showing you how that works with this definition here. So how are we going to simplify the square root of 12 since that is not simplified? So what we do is we want to rewrite the number as a perfect square times something. So I'm going to take the square root sign and I'm going to write 12 in a way so that it's written as a perfect square times the number. And what you want to get is the biggest perfect square. In this case, 4 would be the biggest one, but in some problems, and I'll show you in examples where there's more than one perfect square, you would want to choose the biggest one if possible. Now, using the rule for multiplication with square roots, this could be written as square root of 4 times the square root of 3. And then the square root of 4 could be written as 2. So the answer could be written as 2 square roots of 3. So this is one way of doing it. Now I sort of have a shortcut way of writing that myself. I like to say, well, square root of 12 is square root of 4 times 3. And if it's a perfect square, I circle it. And it's sort of like, you know how when you do long division, you take something out? Here we're going to take it out if it's a perfect square, and we have to take the square root of the number out if I circle it. So I could write it up on top first. That's up to you so that you know what it is. And that goes out in front of the square root sign. So this would give me 2. And then what's left in the square root sign would be the 3 because you took out the square root of 4. So it's a little bit of a way of doing it as a shortcut. So this is one way I personally like to write it to keep track. All right, let's do another one. Let's do the square root of 18. So you have to think, are there any factors of 18 that are perfect squares? Now, if you can't think of any in your head, one thing you could do is divide by 2 and see if your answer is a perfect square. And if that doesn't work, try dividing by 3, see if you get a perfect square, or dividing by 5. In other words, try the prime numbers and see if when you divide into it, if the other number is a perfect square. So that works in this case. 2 into 18 is 9. 9 is a perfect square. So I'm going to rewrite this as 9 times 2. And the traditional way is to write this as square root of 9 times the square root of 2. And then the square root of 9 is 3. Okay, shortcut way, I like to do it this way. I just circle it if it's a perfect square and write what it is up on top. And that way my answer is going to be 3 square roots of 2. Okay? Now, a way for you to convince yourself these are the same is you could get out a calculator and compute the square root of 18. You're going to have to, of course, estimate it with a calculator. It's not going to give you an exact answer since it's irrational. And then you're going to do the same thing for 3 square roots of 2. So use a calculator to simplify the square to 18 and then use a calculator to simplify 3 square roots of 2 and see if you get the same answer. Alright, if you put in the square root of 18, you'll get 4.24264067, etc., going on forever. If you do 3 square roots of 2, remember what you do is first you want to do square roots of 2. Don't round it, and then just go times 3, and you should get exactly the same answer, 4.2426. If you round the square root of 2 first, you might get something that is close to this, but not exactly the same. So that's just a little verification. Alright, so let's see if you could do this problem. Okay, so you're going to see if you could write square root of 50 as the square root of a perfect square times some other number. So go ahead and try it. Alright, how about 25 times 2? And if you didn't see that automatically, remember just divide 2 into 50 and your answer ended up being a square root. So, see? We're going to get 5 gets out, right? The square root of 25 gets out from under that square root, goes out in front, times square root of 2. Okay, let's do another one. How about the square root of 54? All right, so you're going to think about this. You're going to try to write this as a perfect square, right? You're going to write 54 as a perfect square times some other number. All right. Well, from your times tables, hopefully you realize that's 9 times 6. And 9's the perfect square. So you could take that out. 3 square roots of 6. Alright, so this is one way of simplifying the square roots. Now, I told you you might get a number where there's more than one perfect square in it. So I'm going to take square root of 72, for instance. Okay? Some people might notice that that's 9 times 8. Okay? And that's true. And you've got the perfect square 9 here. Okay? You could take that out. But you have to look and see what's left and make sure there's no perfect square that's a factor of 8 as well. So you can go ahead and take that 3 out, but now you have to write 8 as a perfect square times something, since 4, a perfect square, is a factor of 8. So I got to do it again. I'm going to take out the 2. Now what does that mean? When I have a 3 out in front and a 2 up on top, you need to multiply those two together. Okay? So I'm going to multiply those two, and I get 6 square roots of 2. So this is the easier way to do it if you get the largest perfect square. And if you don't know what it is, divide by 2. 72 divided by 2 is 36. 36 is a perfect square. So if you would have noticed that, you could have written 36 times 2 in the beginning, take out the 6, and you would have gotten done with that problem a little bit quicker. This is sort of like reducing fractions. Sometimes you don't divide the top and bottom, the numerator and denominator, by the biggest factor, and then you just have to do it again. All right, so how about if we do something with a number out in front, 3 square root of 75. Okay, see if you could do that one on your own. Hope you paused it and tried it. Alright, so now we've got, that means 3 times the square root of 75. And the perfect square in 75 is 25 times 3. So the perfect square is 25. That comes out. And then what do? We multiply the 3 times 5 to get 15 square root of 3. Just keep in mind, all of these could be verified with a calculator that 3 times the square root of 75 really is exactly the same as 15 times the square root of 3. Alright, let's do some problems with some variables. What if you've got the square root of x to the 15th? Okay, remember if it was even, if the exponent was even, so if you have a variable with an even exponent, then you would take half the exponent, but this isn't even. We're going to do the same thing as if it was with the numbers. We're going to break off one factor of x so that we have x to some even number. So we have x to the 14th times x. And then x to the 14th What's the square root of x to the 14th? Half the exponent, so you could take x to the 7th out, and you have a square root of x inside. Let's try one more. M to the 11th. We'll have m to the 10th times m. That comes out as m to the 5th squared m. We'll continue this on the next video with more examples.